At the end of this module, you will be able to solve problems by using equations of motion. First equation of motion. V equals u plus at, where v is the final velocity, u is the initial velocity, t is the time, a is the constant acceleration of the body. Now, let us do a problem related to first equation of motion. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. Here we have to find the acceleration 2 times. He starts from stationary position and attains a speed of 6 meters per second in 30 seconds. Since he starts from stationary position, we know that initial velocity will be 0. He is starting from rest. So u is equal to 0 meter per second. Final velocity v equals 6 meter per second. And time taken t equal 30 seconds. Finding acceleration. In first case, u equals 0, v equals 6 meter per second, time taken is 30 seconds. So acceleration a is equal to v minus u by t, that is 0.2 meter per second square. In the second case, obviously the initial velocity is u is equal to 6 meter per second. Final velocity v equals 4 meter per second and time taken t equals 4 second. So acceleration a is equal to 4 minus 6 by 5, which is equal to minus 0.4 meter per second square, where the minus sign indicates negative acceleration or retardation. The second equation of motion, which gives displacement time relation. We know that the second equation of motion is that s is equal to ut plus half at square, where s is distance or displacement, u is initial velocity, t is time, and a is acceleration. Let us find the answer of the question. A racing car has a uniform acceleration of 4 meters per second square. What distance will it cover in 10 seconds after the start? Initial velocity u equals 0 since it starts from rest. Acceleration a is equal to 4 meters per second square. Time equals 10 seconds. Here we have the values u, a and t, and we have to find s. So we can use the second equation of motion, which is s is equal to ut plus half at square. By substituting the values, we will get the answer as 200 meters. The third equation of motion, v square minus u square equals 2as, where v is the final velocity, u is the initial velocity, a is the constant acceleration of the body, and s is the displacement travelled in time t. Here we have a problem related to the third equation of motion. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Here we have initial velocity u is equal to 90 km per hour. Acceleration is equal to 0.5 meter per second square. Since the train comes to rest, the final velocity v equals 0 km per hour. Listen, the train is coming to rest. That means it is applying brakes. So its final velocity v equals 0. Since acceleration is in meter per second square, we have to convert initial and final velocity from kilometer per hour to meter per second. For that, we have 1 kilometer is equal to 1000 meter, 1 hour is equal to 60 minutes equal to 3600 seconds. So 1 kilometer per hour is equal to 1000 kilometer per 3600 seconds, which is equal to 5 by 18 meter per second. So multiply the initial velocity by 5 by 18, that is 90 into 5 by 18, which is equal to 25 meter per second. As final velocity is 0, it will be 0 whenever we convert it into meter per second. Now let us apply these values in the third equation, that is v square minus u square is equal to 2as. By substituting the values, we will get s is equal to 625 meter. Therefore, the train will cover a distance of 625 meter before coming to rest.